In this lecture, we will learn bias stabilization and stability factors. After setting the operating point, we do not want the operating point to change, and the main reason for the change in operating point or shift in operating point is change in the collector current IC, because coordinates of operating point are VCEQ, the output voltage, and ICQ, the output current. In my previous lectures, I have represented the coordinates of operating point as ICQ and VCEQ. You can see in this representation I have switched the position of VCEQ and ICQ because generally we represent X coordinate first and then Y coordinate, but in this form of representation I have represented Y coordinate first and then X coordinate. So if you follow the proper nomenclature, you have to represent operating point coordinates like this. The next thing is the stabilization. We do not want the operating point to shift, and the process of making operating point independent of temperature changes and variations in transistor parameters is known as stabilization. So in stabilization, we try to fix the operating point by making it independent of temperature changes and variations in transistor parameters. The next thing is causes of unstabilization. Causes of unstabilization. As I have already told you, the change in operating point is because of change in the collector current. After setting the operating point, it must not change, and the transistor is said to be unstabilized if the operating point changes. So what are the reasons for the change in operating point that we have to discuss in this subtopic? The operating point will change or shift when the collector current IC increases or decreases. The collector current IC will change with change in beta. The collector current IC will change with change in the current gain or the amplification factor, because collector current IC is equal to beta IB plus beta plus 1 ICBO. So if beta changes, the collector current will also change. Now what is the reason for change in beta? Beta is the amplification factor for the given transistor and it is constant. So if we replace the transistor with other transistor, beta will change as no two transistors have the same beta values. So if you replace the transistor, beta will change and also the collector current, and this will lead to the change in operating point. The next reason for the change in collector current is change in temperature. When temperature increases, the reverse saturation current will also increase. ICBO will also increase, and you can see ICBO is there in the expression of collector current. So if ICBO increases, collector current will also increase, and to be more precise, with every 10 degree rise in temperature, the reverse saturation current will double. So 10 degree rise in temperature will double the reverse saturation current. The change in temperature will also change the input voltage VBE. With every degree rise in temperature, the input voltage is decreased by 2.5 millivolts. So input voltage decreases by 2.5 millivolts with every degree rise in temperature. And VBE also affects the collector current IC, because IB, the base current, is sensitive to VBE. VBE is the input voltage and IB is the input current, and when input voltage changes, the input current will also change. They have the characteristics similar to the forward bias diode, and when IB changes, the collector current will also change. So these are the causes of unstabilization, and the next topic is the stability factor. The rate of change of collector current IC with respect to the leakage current ICBO at constant input voltage VBE and amplification factor beta is called as a stability factor. The stability factor is denoted by S, and it is equal to small change in the collector current with respect to the small change in the reverse saturation current at constant VBE and the amplification factor beta. So this is the definition of a stability factor, and mathematically stability factor is equal to DIC by DICBO, the differentiation of collector current with respect to ICBO at constant VBE and beta. Apart from this, two other types of stability factors are also there. The first one is S prime, and S prime is equal to DIC by D VBE, the change in collector current with respect to the input voltage at constant leakage current and amplification factor. The third type of stability factor is S double prime, and it is equal to change in collector current with respect to beta at constant leakage current and input voltage VBE. So these are the three types of stability factors, and we normally have to deal with the first type. Stability factor measures the stability of the system, and lower the value of S, more stable is the system. For example, if we have two transistors T1 and T2, stability factor of transistor 1 is equal to 8 and stability factor of transistor 2 is equal to 5. Now you have to find out which transistor is more stable, and once you have your answer, post it in comment section. I think this is all for this lecture. In the next lecture I will explain how to calculate the stability factor. So see you in the next lecture.